Yes, good afternoon dear senior theories. How are you? Once again, as I promised you, the mode of teaching this time is going to be in this form. So I would like you to appreciate it, but if there is any concern with it, please be open to me and we have ways of modifying it. But I saw it favorable for us because at any time you can resume where you didn't understand and you practice again and you try to understand what you didn't understand previously. Is it okay? So I'm having senior theories right now. Yes. Again, I'm teacher Sam, who is working with you tirelessly. Yes, even in the storms of COVID-19, we have to remain standing. Yes, our president said when the going gets tough, so the tough also has to, the tough also must get going. So if we give up at this time, and yet we have to pursue our goals, so we will have lost everything. So I beg you not to give up at this time. Yes, let's continue studying. Now the other time we talked about ammonia. Yes, ammonia, its physical properties and chemical properties. We talked about them. Okay, so I would argue to go back and read intensively about ammonia. Today I'm introducing you to nitric acid. Yes, nitric acid, we say it is a strong monobasic acid that ionizes completely to produce hydrogen ions and nitrate ions. This is what I'm meaning. This is nitric acid. It ionizes completely to give hydrogen ions and nitrate ions. So we are calling it monobasic because the acid that is given out is it is having only one there. Unlike sulfuric acid. Sulfuric acid gives like 2 hydrogen ions, but here we have only one. We have only one hydrogen ion liberated, but it is by nitric acid ionizes completely. Yes, ionizes completely to give hydrogen ions and nitrate ions. Now unlike ammonia, we said that when ammonia is dissolved in water, okay, it is going to form ammonium hydroxide or ammonia solution. Now that ammonia solution ionizes, but it partially ionizes. This is what we are meaning. Partially ionizes. The equation is in equilibrium. Sorry. There is an equilibrium here. is an equilibrium here, meaning that these products, ammonium ions, can be brought back to the what? To the reactants. Like ammonia gas, when it is dissolved in water, we get ammonium ions and hydroxyl ions, but these ones are in an equilibrium, in that these products can be formed back to the reactants, unlike this nitric acid. For it completely ionizes to form hydrogen ions and nitrate ions. Okay, now what is the laboratory preparation of nitric acid? How is nitric acid prepared in the laboratory? Okay, so you are saying that it is prepared by reacting concentrated sulfuric acid with the potassium nitrate in the presence of heat. Okay, so the potassium nitrate and concentrated sulfuric acid, we are going to form potassium hydrogen sulfate plus nitric acid. Okay, so we are reacting potassium nitrate with the conco sulfuric acid. Okay, in presence of heat. Actually, we are heating these substances in one flask, and we are going to form potassium hydrogen sulfate and nitric acid. This is what we are meaning. If we can check on the laboratory preparation of that, the setup of the laboratory preparation of nitric acid. Here we go. Okay, we have one. You have to know that when we are preparing nitric acid, we are using only glasses. The apparatus that we are using, they must be glass. Why? Because nitric acid is highly corrosive. It is highly reactive with the substances like rubber or wood. So anything like a cork which is rubber and a cork which is wooden, okay, it is going to react with nitric acid, and there we would the reaction will have failed. Okay, by what we do, everything including the cork or the stopper must be glass. Okay, so these glasses are the ones that we call retort glasses. They are called retort glasses. Okay, so what we do, we put concentrated sulfuric acid and potassium nitrate in one flask. This one is a round bottomed flask. Okay, so we heat this substance or this mixture here. Okay, and when we heat them, we are going to form, because we are saying that when we heat potassium nitrate and sulfuric acid, we are going to liberate nitric acid or nitric 5 acid, then potassium hydrogen sulfate. Okay, potassium hydrogen sulfate. This is how the reaction is. So we get potassium nitrate and this concentrated sulfuric acid, and we form nitric acid and potassium hydrogen sulfate. So this is the setup. This is the setup. One, we are using glasses. Why are we using glasses, not rubber or wooden materials? Because nitric acid is highly corrosive. For it being highly corrosive, yes, it will react with those rubber and wooden materials. So we use glasses. Now when the night we're having here cold water, this cold water, its major role is to condense the vapor which is formed here. Okay, the vapor which is formed after the heating in this flask. All right, can go back. Hope we have seen the setup. You will need to illustrate it in your books, please. Yes, don't leave it there. Don't leave it just there. Is it okay? All right. So we are saying that yeah, actually it was put as a note. This preparation is carried out in a special setup called retort glasses. So the setup is entirely made up of glass because nitric acid is corrosive, hence it will attack the cork. This attack is not kulwana, but it is a reaction between nitric acid and the cork, or the cork might be wooden or rubber and even other metals. So we need the setup to be glassy. Is it okay? Yeah. The diagram of the setup was missing there, but you have it now. You're going to use it and draw it in your book. Then we are saying that nitric acid, this is where we are. Nitric acid is produced is slightly decomposed by heat to brown fumes of nitrogen dioxide, which dissolves in the acid formed, giving it a yellow color. So the other time when we are talking about nitrogen dioxide, I emphasize that nitrogen dioxide is a brown, it is observed as a brown, it is observed as brown fumes. So when you see brown fumes in the laboratory, you expect nitrogen dioxide, because other gases in the laboratory, most of them are not colored, but this nitrogen dioxide, its color is brown. Is it okay? So we have this nitric acid. We have said that it is decomposed by heat to give nitrogen dioxide, which is a brown fume, water and oxygen. Okay. Yes. So another note is there. We are saying that sodium nitrate is not used to prepare nitric acid because it is hygroscopic. So we said that water hygroscopic substances. Hygroscopic substances are those substances that absorb water from the atmosphere, but they don't form solution. They don't form a solution. Okay, they just absorb some water from the atmosphere, but they are not forming either a liquid or a solution. They just become damp or wet, but they don't form a liquid. A clear example is copper oxide, quicklime. Okay, that one is a good one. It absorbs water from the atmosphere but does not form a solution or a liquid. Is it okay? So that one qualifies to be a hygroscopic substance. You can also check, we have deliquescent, hygroscopic, and effervescent substances. Deliquescent, those ones absorb water from the atmosphere and form a liquid. A good example is sodium hydroxide pellets. Those ones absorb water from the atmosphere and form a liquid. So if you leave sodium hydroxide pellets on the table for like 10 to 20 minutes, you'll come back and find that the pellet that you left on the table is no longer a pellet, but it is either a liquid or a solution. Okay, then 2, hydrochloric acid. This is where we are. Hydrochloric acid and nitric acid are volatile, so we don't use hydrochloric acid here, and we don't use nitric acid here also. Why? Because they are volatile. Bifumuka mangu. Okay, bifumuka. So what we commonly use is concentrated sulfuric acid, because it is non-volatile and replaces volatile acids from their salts. Okay, so there, the acid that we must use is concentrated sulfuric acid. Okay, we have said that we don't use sodium nitrate, but we use potassium nitrate. Why? Because we have said that sodium nitrate is a hygroscopic substance, so we need potassium nitrate, which does not absorb water from the atmosphere. Okay, yes. Wow. Now let us see how nitric acid is prepared in the industrial preparation of nitric acid. Okay, when we want to obtain nitric acid at a large scale, we prepare it industrially. Yeah, we prepare it industrially or in an industrial process. How? We say that the nitric acid in the industry, the industrial preparation of nitric acid, we use catalytic oxidation of ammonia. We use catalytic oxidation of ammonia. What is it? So we said that the other time when we are talking about ammonia, we said ammonia reacts with oxygen in the presence of a catalyst, and we form nitrogen dioxide. Okay, so now in the industry we use that approach and we use a catalyst in the oxidation of ammonia. So what happens is ammonia is mixed with excess oxygen in the presence of a catalyst, and that catalyst is either platinum catalyst or or yes, you will answer that. You will answer that. Is either platinum catalyst or a copper wire. Okay, to produce nitrogen monoxide and water. The reaction produces a lot of heat. So ammonia, when ammonia is heated with oxygen in presence of platinum catalyst, we first form nitrogen monoxide and water plus heat. Then that mixture of nitrogen monoxide is cooled, and nitrogen monoxide is mixed with excess oxygen to give a reddish brown film of nitrogen dioxide. This one. Okay, so then that nitrogen monoxide formed is mixed with more oxygen and dissolved in warm water to produce nitric acid, which contains 68% nitric acid and 32% water. Yes, so there we shall have formed nitric acid using industrial processes. Remember that we said that in the laboratory we prepare nitric acid using potassium nitrate and concentrated sulfuric acid. Okay, but here in the industrial preparation we use catalytic oxidation of ammonia gas, where the ammonia is reacted with oxygen in the presence of a platinum wire. Okay, presence of a platinum wire. We first form nitrogen monoxide, then the nitrogen monoxide is mixed with excess oxygen to give a reddish brown film, which is nitrogen dioxide. Then the nitrogen dioxide formed is mixed with more oxygen, and dissolved warm water to produce nitric acid, which contains 68% and 32% of water. So you check this. Sorry. Check on this. This is nitrogen dioxide, which is mixed with oxygen. This nitrogen dioxide mixed with the oxygen, and they form nitric acid. All right. What are the conditions for the reaction for the industrial preparation of nitric acid? 1, it is carried out in the presence of a platinum catalyst. 2, high pressure, which are 8 atmospheres, then excess oxygen gas. Those are the conditions. Because it is the process is called catalytic oxidation of ammonia. So we need a catalyst and we need oxygen. Okay, we need excess oxygen, which will oxidize the ammonia. All right, so those are the conditions. 1, presence of platinum catalyst or platinum wire, high pressure, and excess oxygen gas. Okay, then we have, let's talk about the uses of nitric acid. 1, it is used in making of plastics. Then it is also used in the manufacture of fertilizers, e.g. ammonium nitrate and urea. Yes, these ones are common to agriculturalists. Urea. Urea is commonly used by agriculturalists. The same applies to ammonium nitrate. To ammonium nitrate. They are all common. They are all common fertilizers we normally use in our gardens. So when you go there and you start to if you are to start your project in agriculture, so these ones are good fertilizers in your gardens. Another use, nitric acid is used in the manufacture of explosives, ebyo ebibwatuka eg trinitrotoluene. Yes, those hard words, you have to know them. Otandika okukanga abatuuze ku kyalo bakusanga okwogedde trinitrotoluene ne baga atusse. Okay. The note is a mixture of concentrated nitric acid and concentrated hydrochloric acid in equal volume is used to test for the presence of gold. So all substances dissolved in the above mixture, but gold remain. So if it remains, it will be obtained. Okay, so nitric acid can also be used to test for the presence of gold. Okay, presence of gold. So it is used in the in testing of the presence of gold. That is when nitric acid is mixed with concentrated hydrochloric acid in equal volume. Okay, yeah. What are the physical properties of nitric acid? 1. It is a colorless volatile liquid. However, it appears yellow in color as it contains dissolved nitrogen dioxide. It is very corrosive. It is a corrosive acid, and this reason it is stored in glass containers, not rubber or cork, as they will react with them. I'm introducing nitric acid. Okay, what are now the chemical properties of nitric acid? Okay, so these chemical properties are divided into two. 1, acidic property and oxidization property. For any acid to qualify, for any substance to qualify to be an acid, it must have these two properties. It must have an acidic property or an oxidizing property. Okay, now acidic property, nitric acid, it behaves as an acid when dilute. It turns a blue litmus paper red, liberates hydrogen gas when reacted with electropositive metals. Okay, and we are saying that only calcium and magnesium react with dilute nitric acid. Okay, those group 2 metals. So when we react, if the so-called acid fails to liberate hydrogen gas with calcium or magnesium metals, then that one is not a strong acid. Okay, is not a strong acid. So This nitric acid is an acid because it can liberate hydrogen gas when it reacts with electropositive metals, for example calcium and magnesium. According to those equations, magnesium with nitric acid, we get magnesium nitrate and hydrogen gas. With calcium, nitric acid forms calcium nitrate with hydrogen gas. Okay. 2. For it to be called an acid, it must liberate carbon dioxide from carbonates and hydrogen carbonates. Okay, because we know, if you know that carbonates, when any carbonate or hydrocarbonate is reacted with an acid, we are supposed to liberate carbon dioxide and water. So if an acid fails to liberate carbon dioxide from a carbonate or a hydrocarbonate, then that one is not an acid. So nitric acid, it is an acid because it liberates carbon dioxide from carbonates and hydrogen carbonates. For example, calcium carbonate, when it reacts with nitric acid, we are going to form calcium nitrate, carbon dioxide. The moment you see musajja mukulu ono being liberated, the moment you see basajja bakulu bano being liberated, okay, and this, just know that that one is an acid because it has managed to liberate carbon dioxide and water from carbonates. Okay, so when nitric acid reacts with calcium carbonate, we form carbon dioxide and water plus a respective nitrate, a respective metal nitrate. Calcium carbonate liberates calcium nitrate, carbon dioxide and water. Lead nitrate liberates, when it reacts with nitric acid, liberates its respective lead nitrate and carbon dioxide plus water. Copper 2 carbonate, when it reacts with the nitric acid, we get its respective copper nitrate, okay, with and carbon dioxide and water. So if an acid fails to liberate the carbon dioxide from a carbonate, okay, and from a carbonate, then that one is not an acid. So nitric acid qualifies to be called an acid because it has that ability. Okay, it reacts with bases to form salt and water. There we are. Nitric acid reacts with the bases forming salt and water. So for example, actually this one we say an acid, for it to qualify to be an acid, it has also to form salt and water when it reacts with a base or an oxide. Okay, so nitric acid qualifies to be an acid because it forms a salt and water from any metal hydroxide, which is a base, or any metal oxide. Okay, so for example here we have a base which is sodium hydroxide, reacts with nitric acid, we form sodium nitrate. this nitrate is a salt. Ojja kuŋŋamba nga sirabamu nnyo wano eno. So this is a salt. This is a salt. This is a salt, and this one is also a salt. Okay, so it can also liberate a salt and water when it reacts with an oxide. At this time we have used the zinc oxide. Even if you use calcium oxide, even if you use copper 2 oxide, we must liberate a nitrate, which is a salt, and water. Alright, and also for it to be a strong acid, it must liberate hydrogen sulfide from sulfites. Yes. So because nitric acid has the ability of doing all this, it qualifies to be an acid. Okay, it qualifies to be an acid because it has those acidic properties. Now let us see its property as an oxidizing agent. Okay, so remember we are talking about chemical properties of nitric acid. The first property we have said it has acidic properties. Okay, then the second one is oxidizing properties. So nitric acid is a strong oxidizing agent, and this takes place when the acid is concentrated. When the acid is concentrated. During the reaction, the acid is reduced to nitrogen dioxide and water. Nitric acid is a strong oxidizing agent, and this takes place when the acid is concentrated. During the reaction, the acid is reduced to nitrogen dioxide and water. For example, when we are reacting with the copper, remember the nitric acid must be concentrated. We are saying that with the concentrated nitric acid, in the presence of heat, copper is oxidized to copper 2 nitrate, and the acid is reduced to nitrogen dioxide and water. Now here we have copper. We have our copper here. We have our copper here. Sorry. We have our copper here. Okay. We have copper 1. Here it is copper 1. But to form copper, this compound, this copper is now oxidized to copper 2. Okay, I've said this is copper 1, and now here it is called copper 2 nitrate. That means it has been oxidized from copper 1 to copper 2. Is it okay? And the nitric acid here is reduced to nitrogen dioxide and water. So it has these oxidizing properties. Nitric acid has those oxidizing properties. 1, it oxidizes copper to copper nitrate, and the nitric acid itself is reduced to nitrogen dioxide and water. Hope we are following. Let me hope we are following. Then with moderate concentrated nitric acid, nitrogen monoxide is formed instead of nitrogen dioxide. Okay, instead of nitrogen dioxide. So when you reduce the concentration, or the more when you are diluting the nitric acid, its oxidizing property reduces. Okay. So in the same reaction, copper, when copper is reacted with nitric acid, we are going to form copper to nitrate plus nitrogen monoxide and water. This reaction occurs when the concentration of nitric acid is moderate, not highly concentrated. Is it okay? But when it is highly concentrated, it reacts with the copper, forming copper nitrate and nitrogen dioxide, which is a reddish brown fume. All right. Nitric acid does not react with iron and aluminium during its oxidizing property because it renders the two metals passive. It renders the two metals passive, or unreactive by adding more oxide layer on the surface of the metal. The oxides prevent acid from reacting with the metal. So someone may ask explain why nitric acid does not react with the iron and aluminium. Okay, the reason may be nitric acid renders the two metals passive by adding more oxide layer on the surface. Okay, so those oxides are the ones that prevent the acid from reacting with the metal. Okay, let's see how it reacts with non-metals. For example, carbon. Concentrated nitric acid is reduced to water and nitrogen dioxide and itself oxidized to carbon dioxide. So when we react nitric acid with the carbon, we are going to form nitric acid. When carbon is reacted with nitric acid, we are going to liberate carbon dioxide and nitrogen dioxide plus water. A question may be, concentrated nitric acid was added was added to carbon, full stop. State what was observed and write the equation. What is actually observed? You write two observations here. When we say concentrated nitric acid was added to carbon or was reacted with the carbon, and they ask you to state what was observed. What was actually observed are these two gases, carbon dioxide and nitrogen dioxide. How do we test for them in the laboratory? One, carbon dioxide, it is a colorless gas. It is a colorless acidic gas, and it turns lime water milky. Okay, then this nitrogen dioxide, for it is a reddish brown fume. So in this reaction, we are going to see a colorless gas that is acidic, and it turns it turns lime water milky. Okay, then another gas, which is a reddish brown gas, okay, are observed. When they ask you to write the equation for the reaction, you write this, you write that one. Okay, let's see the reaction with sulfur. Nitric acid oxidizes sulfur to sulfuric acid and itself reduced to nitrogen dioxide and water. Okay, so sulfur reacts with nitric acid and we form water, nitrogen dioxide, and we form sulfuric acid. You check this, it should be, because we are saying that sulfur is oxidized to sulfuric acid, and itself reduced to nitrogen dioxide. So we are saying you check on this, it should be written like this. So this is sulfuric acid. So that one there, it is this one is sulfuric acid. This one is sulfuric acid. You're going to change it. Then with the potassium, with the phosphorus, it is the phosphorus is oxidized to phosphorus acid. Then the nitric acid is reduced to nitrogen dioxide. This is the equation. This is the equation, this one. So phosphorus reacted with nitric acid, this is the nitric acid, this one, plus so the phosphorus reacts with the nitric acid and we form phosphoric acid, nitrogen dioxide, and water. Yes. That is how it is. All right, that's all about nitric acid. I would beg to first pause at this point before we go to nitrates. We shall study it another day. Yes, so today's lesson is has been all about nitric acid. Hope you're going to understand more about nitric acid. I'm going to send you some videos about nitric acid. The other time I sent to you videos of ammonia, especially that reaction with water, ammonia with water, solubility of ammonia in water. Hope you watched it very well, and I had promised you peace to discuss it. So anytime I'm going to schedule a Zoom meeting. Yes, then you're going to discuss for us. You read in that textbook, compare it with the video, then you'll be able to discuss for us. Okay. I wish to end here. I salute you all, and I wish you a happy Sabbath. Twayimbanga gwe gundi olaga wankulaba oyambadde onyumye nnyo, ngenda kusaba anti leero Sabbiiti. So I wish you a happy Sabbath. Amakanisa baagaggala, mulekerawo okusabira ku masimu ne ku social media. Mugende mutwale ebitabo bya Bayibuli, musome Matayo ne Timoseewo. Yes, otherwise I wish you well, dear friends, but in any case of a concern, please, I'm here to listen to you. Don't die with your problem, okay? And anything that you see that must be changed, please tell me, and we change accordingly. I want to assure you that we are going to repair the plane while we are flying. Yes, this one is good. It's not highly data consuming. Yes, I know you're going to see it. You download it once, and you study for a full hour listening to my voice, okay? And you, after watching it, even tomorrow after Sabbath, you may want to replay it, and you understand it more, okay? And you understand it more. One problem with it, I know you may take it for granted that after all I have it in the phone, I play it when I get time. Please, just know that this is a lesson for today. Even on Sunday, I'm going to send you another one. Even on Monday, operation tewali kuzikiza. Buli lunaku. Yes. Otherwise, nice time. I wish you the best. I salute you, and I remain Teacher Samuel.